Welcome to this lesson on linear inequalities in one variable. Inequalities are mathematical expressions that show the relationship between quantities that are not equal. We use symbols like less than, greater than, less than or equal to, and greater than or equal to represent these relationships. A linear inequality in one variable is an expression that can be written in the form ax plus b is less than 0 or ax plus b is greater than 0, where a and b are constants and is not equal to 0. Some examples of linear inequalities include x is less than 5, 2x plus 3 is greater than or equal to 7, and negative x minus 4 is less than or equal to 2. Let's discuss the rules for solving linear inequalities. Rule 1. We can add or subtract the same quantity from both sides of an inequality without changing the direction of the inequality symbol. Rule 2. We can multiply or divide both sides of an inequality by a positive number without changing the direction of the inequality symbol. Rule 3. If we multiply or divide both sides of an inequality by a negative number, we must reverse the direction of the inequality symbol. Let's understand why we need to flip the inequality sign when multiplying or dividing by a negative number. Consider the inequality x is less than 5 on a number line. It means x is to the left of 5. Now, when we multiply both sides by negative 1, we get negative x is less than negative 5. But on the number line, negative 5 is to the left of negative x. So the correct way to write this is negative x is greater than negative 5. Let's solve some examples of linear inequalities. Example 1. Solve the inequality x plus 3 is less than 7. Step 1. We subtract 3 from both sides. X plus 3 minus 3 is less than 7 minus 3. Step 2. Simplify. X is less than 4. So the solution is x is less than 4, which we can write as x belongs to the interval negative infinity to 4. Example 2. Solve the inequality 2x minus 5 is greater than or equal to 3. Step 1. We add 5 to both sides. 2x minus 5 plus 5 is greater than or equal to 3 plus 5. Step 2. Simplify. 2x is greater than or equal to 8. Step 3. Divide both sides by 2. X is greater than or equal to 4. So the solution is x is greater than or equal to 4, which we can write as x belongs to the interval 4 to infinity. Example 3. Solve the inequality negative 3x plus 2 is less than 8. Step 1. We subtract 2 from both sides. Negative 3x plus 2 minus 2 is less than 8 minus 2. Step 2. Simplify. Negative 3x is less than 6. Step 3. Now we divide both sides by negative 3, but remember, when dividing by a negative number, we must flip the inequality sign. X is greater than negative 2. So the solution is x is greater than negative 2, which we can write as x belongs to the interval negative 2 to infinity. Let's look at a real-world application of linear inequalities. Problem. A movie theater charges $12 per ticket. The theater needs to make at least $600 in ticket sales for a particular showing. How many tickets must they sell to meet this goal? We can formulate this as a linear inequality. Let x be the number of tickets sold. Then the revenue from ticket sales is $12x. We need this to be at least $600. So we have the inequality. 12x is greater than or equal to 600. Dividing both sides by 12, we get x is greater than or equal to 50. So the theater needs to sell at least 50 tickets to meet their revenue goal. To summarize what we've learned about linear inequalities in one variable: 1. Linear inequalities use symbols like less than, greater than, less than or equal to, and greater than or equal to. 2. To solve linear inequalities, we follow similar steps as solving linear equations, with one important difference. When multiplying or dividing by a negative number, we must flip the inequality sign. 3. Solutions to inequalities are often expressed as intervals on the number line. 4. Linear inequalities have many real-world applications, such as minimum requirements, maximum constraints, and ranges of acceptable values. Understanding linear inequalities is an important foundation for higher-level mathematics and for solving many real-world problems. Thank you for watching.